Hey guys, this is Adam and I'm back with another video. This time I want to talk about Azure Storage Queues. Simple but very powerful messaging service in Azure. Stay tuned. As always, let's start with basics. Queue Storage is a service that was created for the purpose of storing large number of messages. It is also currently a sub-service of storage account within Azure. Therefore, if you've been already using Blob storage, then you already have access to the queue storage itself. So how does it work? First of all, it's part of the storage account, so it takes all the best features of the storage accounts like zero application, security, high scalability, but one important thing is to note that it can only process 20,000 messages per second. Only is maybe a stretch because that's a lot of messages per second, but it's only 20,000 on entire storage account. That's a limit you cannot exceed, and this assumes a 1 kilobyte message in this estimation. Second of all, under each storage account you can have one or multiple queues, usually separate queues by your business logic, like you can have incoming, outgoing orders and returns and process them separately. But each queue is a container for your messages and it can store up to 500 terabytes of data. So it's pretty much limitless scalability. But a single queue can only process 2000 messages per second. So if you need more, take a different approach. If you can't live with it, maybe scale across multiple queues or maybe even multiple storage accounts. It's up to you. Under each queue, you have messages, and a message is pretty much data in any kind of format: JSON, binary, text, CSV, etc., etc. A single message can be only up to 64 kilobytes of data. And you cannot exceed it, it's a hard limit. But it's a good limit because messages should be small. You should only send key information and pull everything else from your database or any other data storing solution. Additionally, there's something called time to live. So when you put a message on a queue, by default, if no one picks it up, it will be there for 7 days. After 7 days, it will expire and get deleted automatically. But you do have an option for non-expiring messages. You simply set that TTL, time to live, to -1, although it's not the greatest approach, so always reconsider that. So why would you want to use the queues? Let's take a simple scenario where you have a storage in your SQL, where you store your data, and you have your applications where, let's say for each of 100 users, you're gonna have one instance of your web application just to scale up. And when new users will start coming, you will auto-scale with another application. But during heavy period traffics, you might encounter some issues. Maybe your database is too small, maybe your backend API is not good enough. You will hit those blocks and your application will start failing. How can you handle that scenario without simply increasing the database? Because you could always, as they call, throw a hardware at the problem, but that's not the best design. You can actually solve this challenge without paying more by adding a simple queue here and outputting all the messages to the queue, and then having some function handler or any other API that will grab these messages from this queue at very steady rate that your database can handle. This will pretty much flatten out, so-called load level, your application workload so that you can actually have everything like you just had, introduce very small components that don't cost more, and pretty much get the scalability that you would want. Of course, you would see some slowdown on the request for the users, so definitely something that you should consider. One of additional scenarios that you can handle with queues is something called fan-out. So you have your user sending requests to your web application is putting messages in a queue. But what is awesome here is that you can then create functions that will scale depending on a queue size and pick messages separately and process them in parallel. This is so-called competing consumers pattern, and it's an amazing way to scale your applications separately, and it's one of the core features of how serverless in Azure actually works. But let's talk about one of the best benefits of using the queues, which is retries. If you have your web application in a queue, and your web application sends a request to get the message from the queue, what the queue service does is put this message as a hidden and then returns the message to the client, also with something called pop receipt. So a receipt for the client, so that this client is currently processing, every other client application cannot see this message. It's hidden from everyone else, but it's not deleted. It's very important to note that. Then when your web application process this message and it would encounter an issue, what would happen then? Well, in this state, the message is still hidden and this web application never processed the message. So we have an issue. But queues solve this issue by having something called visibility timeout. So after a certain period of time, this message will be visible again. And at that point, your web application or any other web application connected to this queue can get that message again and put it as hidden, get it back, get the POP receipt again, and process it. And if you process it properly, you can then send a delete request to the queue with the POP receipt that you got previously, and then and only then message is being deleted. What's important here? Notice that you actually have to respond back after getting message that you processed it successfully, and until then it's still on the queue, it's just not visible. This gives you very highly resilient architecture, which allows you to create applications and retry multiple times, because when programming, something might happen, not only your code, but also cloud. In cloud, you always can get failed requests because all the services within Azure have some sort of SLA. By having this queue, you are making your architecture more resilient by very low effort and pretty much no cost at all. So definitely one of the best things about queues. What are the support authorization methods? Because you are using storage accounts, you're pretty much getting the same options. First of all, you have account key. This is like a password for your entire storage account, including the queue service. You can also generate shared access signatures, so define what kind of actions on which API, which IP or which protocol can it connect to, and how long does the token is actually valid for, so that you can get much more granular with your accesses. But the best way is using Azure Active Directory, so you can create those service accounts or give actual users accounts RBAC roles, which is role-based access control. Those roles, currently there are 4 built-in: storage, queue, data contributor, reader, message processor, and message sender. As you can imagine, contributor is like an admin, can do everything on the queue. Reader can only read messages, but cannot pop them, so it cannot process, can only see what messages are on the queue. Message processor, on the other hand, can read everything from the queue, can process the message and take them away, so delete the messages, but cannot create any messages. And on the opposite side, message sender can only send messages, but cannot read or process the current messages on the queue. With this, you can actually get very granular, and this is very, very secure. I would say Azure Active Directory is always recommended method when it comes to security in any kind of applications. If your service in Azure supports it, always and always use it. Before we go to demos, let's talk about some key information that are very important. Every single operations within the queue is atomic, so you're always sure that your get message is end-to-end transaction that cannot be split. But when it comes to transactions itself, the queue service doesn't support those. So what this means, you cannot, for instance, send 10 messages and be sure that all 10 were committed. You can only send message one by one, and if you send 20, let's say 19 can fail, and it's not gonna roll back those 20 that you sent. So there's no transaction across multiple operations, and there's no batching like that. So if you need that, definitely look different services like Service Bus. And also there's available SDK, so you have .NET, Java, pretty much most of the popular languages have SDK for storage accounts and for the queues, so definitely check those out so you don't code the API from the ground up. And the demos. Today I will show you how to create a queue service, how to manage the data using Storage Explorer and the portal, and then we're gonna do a very simple fan-out demo where I will create 2 LogicUps and a queue service, and I will chain those together and show you how can you actually put the data into the Blob storage in parallel using multiple LogicUps from the same queue. And of course in the diagrams you don't really have to draw those, usually you draw it like this. So let's go into the demos. Let's start by creating queue storage. Let's go to create resource, and you don't type queue, you actually go to the storage account and you need to create a new storage account. I'm gonna create a new resource group for this queue storage introduction. I'm gonna call my storage account AM demo storage 01. I'm gonna choose the North Europe. A performance for me will be standard in version 2, everything else as default. Hit create. validate selection, and hit create again. Once the storage account was provisioned, you can go to the resource and you'll actually see the classic stuff when it comes to storage accounts, and one of the 4 services that you will see is a queue service. When you go here, you will actually not see much. You can actually hit button add queue to create new queue. I'm gonna call it messages. Hit OK. Notice that when I created messages, a new URI was created with the address of my storage account /messages. You can open that queue, and as you see, there's not much you can do here. You can only add messages and dequeue messages and clear entire queue. This is the first place where you can actually manage data and see what is on your queue. You can actually hit add message, and here you need to fill in the message text like demo. And you can put what is the default TTL, which is what is the expiration date, by default 7 days. And you can encode the body in base64 or not if you want. Hit OK. And you can add a couple messages like that. You can add the message of the same text if you want. It doesn't really matter. At this point, you can dequeue the message if you want to remove something or clear entire queue. So this is the first part of interaction with the queue. If you go back, you can also review it from the Storage Explorer. In the portal, you have Storage Explorer, or you can download the desktop version. I always advise to download the desktop version because it has a lot more features and it's much quicker to work with. But you can open in the portal, the queues, messages, and pretty much review the same stuff, like just before, demo message, and almost the same experience that we just had a second ago. So you don't really get much more for the queues. For the Storage Explorer, you get much more for order services. For the queues, it's very simple. In this case, let's close this one. And let's start creating the logic apps. So we need 2 logic apps right now. So let's hit create resource, hit logic app. Let's hit create, call it logic app 1. Use existing resource group, in this case our queue storage introduction in North Europe as well. Hit create. And we need another logic app, so I'm just gonna create both of them at the same time. Logic app, hit create, call it logic app 2. And also within the same resource group for the queue storage introduction, hit create, and we're good. If I will go to my storage intro resource group, I can refresh here. The refresh sometimes takes a couple of seconds, but if you don't want to wait, you can hit on this notifications and go here to the empty workflow and hit go to the resource. It will take you directly to logic app. Once you created the logic app, let's start from the blank one. Since I want to create it and started using this run button here, I'm just gonna go to all and type request, or actually use it from the most common ones. And when HTTP request is received, this will pretty much create a public URL for me to call, but I also can call it using run button, because this is just any kind of trigger for me. It doesn't really matter. So what we really do want to do is add a message to the queue. So let's type queue to find the connector for the queues. And inside of the queues, as you see, there's a couple of actions here, but what we want to use is the put message on a queue. It will ask me which storage account do you want to connect to create a connectivity. So queue connection, for the connection name, I'm gonna choose AMDemo storage 01, hit create. This right now saves the credentials to my storage account to the queue. And now I can choose the queue that I want to put the messages on, which is the messages, and give it the message. I'm gonna call it demo, and maybe append something dynamic. So I'm gonna choose add dynamic content, expression, and type rand for some random generated number from 1 to 10,000. And that will be the message that I will output there. Let's hit save, and let's hit run. In a second tab, I will also open Azure Portal so that I can edit the logic app, but at the same time look what is inside of my queue. As you see, this logic app ran just successfully, so we can now go and review the messages on the queue. So open our resource group, open the resource group that we were currently working on, go to the storage account, and as I said, you can either review in the queues or the storage explorer, open the queues, messages, and as you see, randomly generated message. I'm gonna clear entire queue right now. So let's do a bit more challenging demo, shall we? Let's open Designer and let's add a very small loop. In this case, I'm gonna use loop, which is the control action, because I want to do a loop of 10 iterations. Click on the control and do for each. In here, you need to specify what is the object, or you can simply give it an expression with the array list. This pop-up is not the best, but what I did is a very small array with 1, 2, 3, 4. And then put it inside of that for each. And simply hit save. You can now run this, and if this works correctly, it will iterate 4 times over this array and send 4 random messages to our queue. Let's see the result. As you see, it runs successfully. You can review each iteration and review what kind of message was randomly put on our queue. And you can then revert to the queue to refresh and see the messages. So we have the first part done. We have now LogicUps which are currently outputting the messages to the queue in a loop. So now we need to create the second LogicUp. I already created it, so I'm just gonna close this, go back to the resource group, and use the second LogicUp to trigger based on a first LogicUp output on a queue. So I'm gonna open it. I always start from the blank. I'm gonna type queue, but it's still gonna be visible on the recent. So hit queue, and as you see, when a specified number of messages are in a given queue, or where there are messages in a queue, there's not much difference between the two. In the first one, you can also specify batch on how many those messages you want to wait for. So when there are messages in a queue trigger, I want to use my messages, since the connectivity was already saved. I want to check every 10 seconds, and mostly because I want very quick demo. And that's good. At this point, I'm gonna save it just to show you something interesting. I'm gonna save this LogicUp, and I will go to the LogicUp overview and hit refresh, because notice it ran 4 times. So it actually detected those 4 messages on a queue. If you go into each of these messages, you will see that a message queue was checked, and it took the information, including the message text. So it's already getting the body of the message. But interestingly, if we'll go back to the queue and hit refresh, you will notice that messages disappeared, but at the bottom you will see showing 0 out of 4 messages in a queue. Therefore, those messages are still there because we never actually deleted them after taking them, because we need to send that delete request with that pop receipt that we got. Otherwise, after 30 seconds, which is the default visibility timeout, they will reappear on the queue. Therefore, when you're designing a LogicUp like that, you need to go back, hit edit, and add additional step. In which case you need to go to queue, and then delete message action, select messages queue. You need to provide a message ID, which you have from the first step, and need to provide a pop receipt, as I said. So you also need to add that. So let's save that in, and let's go back and run our first LogicUp. So let's run the manual trigger, and let's hit refresh a couple of times. As you see, the new messages are running in the queue, showing 4 out of 8 messages. And if I hit refresh, showing 8 out of 8. So as you see, they came back to life. Hit refresh. After a couple of seconds, the second LogicUp should run. So we can actually go and start reviewing the history. And as you see, it did process 8 additional messages. If this succeeded, if we go here and refresh, as you see, there are no messages in the queue. That's definitely very important behavior of how queues work with other services. You need to be aware of that, and you need to be prepared that you will be processing the same message twice if something happens. So make sure you don't add to database. You should always merge with existing entities if you find any, etc, etc. Make sure that logic is resilient enough that you can actually reprocess the same messages. So the very last thing that we're missing is this saving to Blob from our demo, where we're actually gonna show how to process multiple messages at the same time and output them as a file. So if you go edit, add a step in the middle, add an action, type Blob, hit Azure Blob Storage, create Blob, to the same storage account, Blob connection, hit create. So let's grab the message that we're sending from the queue and save it as a file. Right now we don't have any container, so we need to go back to our Storage Explorer and create new Blob container called demo. And inside of this container, we're gonna store our files. We're gonna name that file randomly. We can, for instance, use message id.txt and then use the content. So we need to click see more and get the message text to use it as a blob content. Let's hit save and rerun the LogicUp 1. Run the trigger and go to the storage account, go to demo container, and you can start refreshing, because after 10 seconds we should start seeing 4 blobs here stored. As you see, we got 4 more files. You can open the contents, demo. This is how easy you can from one LogicUp span across multiple LogicUps, which will process the messages in parallel and pretty much connect to external services, making very highly scalable architectures in your applications. I think we can all agree that storage queues are very simple but powerful service that allows you to do very cool stuff with your applications. They're a critical part of any web application and microservice architecture in Azure, so you should definitely use them. For today, that's it. Hit thumbs up, leave a comment, subscribe if you want to see more, and definitely see you next time.